Hi, I thought it would be good to have a look at Module 3 and just talk a little bit about that. So far, most people have completed Module 1, that's great. Several people have completed Module 2, and I think most people are working on Module 2. Keep going, get that done this week. So next up is Module 3. And Module 3 is an important module because it's a stepping stone to where we need to get to. So far you've been using Microsoft Access, which is a nice little database. It's got a nice interface. It's available on most Windows platforms with an Office subscription. So it's good. The trouble is, it's got a few problems, Microsoft Access. One of them is it doesn't work well with people distributed over a large area. It doesn't network well. It doesn't deal with large data. You might have heard of big data. A lot of companies deal with lots and lots and lots of data, and Access doesn't necessarily work with that well. So we need to get to talk about SQL Server, which is Microsoft's bigger database, or MySQL, which is an open source database that's a bit more performant than Microsoft Access. But before we get to those two, we need to talk about another way of writing queries, and that is SQL, the structured query language. And this is available in Microsoft Access. It's available very easily, but we haven't looked at it much yet. So the way to do it is, let's just quickly have a look at, actually I had wanted to have a look at the relationships table first. What I did is I downloaded the Module 3 JC Consulting ACCDB file and have a look at it, and we'll notice that the employees table in this one, it now has employee ID as primary key, and it's got employee ID on the projects table as a foreign key back to the employees table. So that's a nicer setup. What we've done before is, when we've been looking at queries, we've been looking at two main views. One view is this view, which is the datasheet view, which is the result of the query on the current database. And the other view is the design view, which is the graphical user interface version of what we're doing with the database, right? And that works pretty nicely. What you may have noticed is that there's a third option. There's the SQL view, right? And SQL's a little wordy, and this one isn't necessarily formatted as nicely as you might like, but it is text. And the nice thing about SQL compared with that graphical version is most SQL will translate onto just about any other relational database. I could take this and run it on MySQL, and it should pretty much run. I could take it and run it on SQL Server, and it also should pretty much run, provided the same data tables were there in those other databases. So it's something we've got to learn about, and that's where we're going next. And like I said, it's pretty easy to see to get to from within Microsoft Access. It's one of the three views into designing a query, which is kind of nice. Now let's have a look at the overview, right? So I've shown you how to open at the SQL query window. I haven't shown you how to change the font size. I hadn't realized how to do that. So the way I get there is I go to File, options, and then object designers, query design, and then I change the font size here. I might even change to a different font. I actually tend to prefer Consolus as the font. If I can find that there we go, right? And that should have changed my font to Consolus. I don't know whether it did. Let's open it up again and have a look again. Yeah, there we go. That's more like Consolus font. Consolus is nice because it's what's called a fixed width font. It looks a little ugly if you're used to reading standard documents, but from a coding viewpoint it's nice to have each character the same width so that tabs line up and everything works nicely. Okay, let's go back here. So, oops. Did I get there? No, I didn't want to go there. I want to go back to full book and there, and go back to the table of contents and go back to there. There we go. Right, so the things we want to look at, first of all, how do you make a table in SQL? How do you read or select data in SQL? How do you make compound conditions, more compound conditions and logical operations? How do we make calculated fields? How do you use wildcards and in and like operators? How do you sort stuff? How do you use aggregate functions? How do you group records? How do you write a subquery? What's a subquery? How do you join tables? What does that mean? And then updating, inserting and deleting data are the three main operations you want to do, other than querying the database, and then we can save results in a separate table. Okay, so I'm not going to go into excruciating detail, but let's just quickly have a look at this, right? So it's always important in just about every coding environment to have coding, or rather naming conventions. Coding conventions more generally, but specifically naming conventions, right? So make sure that you understand how you can name things, right? You can't have names with reserved keywords. You can't have names longer than 64 characters. You can't use period, exclamation point, graph, or square brackets. Table and field names may not start with a space. They can have spaces in them, though I recommend against it. You should use not use control characters, and you shouldn't use the double quote mark. Okay, so that's pretty much it. I think I spoke before about whether to name the table as the plural or not. I tend to prefer naming tables as the plural, so users, clients, projects, zips, that sort of thing. But that's really up to you, or eventually later on in this course your group, to decide what your naming convention is. So data types, it's shown a little differently between the graphical version and the SQL version, right? So auto number is usually what you use for an primary key field, employee ID, client ID, but the type is probably something different when you're trying to create the table using SQL. Some of them are similar. Currency is just currency. Date/time is just date time. Long space text is long text without the space. Right, so there's slight differences. And here's an example of creating the table clients in SQL. Right, this looks pretty similar to the JCC clients table. Right, let's just have a look at the design view. Right, we've got client ID, we've got three short texts, and we've got yes, no. Right, client ID, three short texts, and these have different values. I don't know whether we've got the length here. That's 35, that's 25, you can see the number there, and that's 5. So I think that works pretty well. But this is the way you do it using SQL. Right, to select data, you use the select statement. Right, and here is an example: select client ID, comma, client name from clients. Right, and let's just go here and make a new query. So we're going to go with the query wizard, and we'll just do a simple query. We've got the client ID and client name, and we'll just do that. Okay, now let's have a look at the SQL. Right, there it is. Select clients.clientID, comma, clients.clientName from clients. There's a keyword, select, that tells you the things following the select are the fields or the attributes or the calculated values or the aggregate values that you're going to put in the result of this query. And then from is the indicator that this query relates to this table. In this case, clients. It may relate to more than one table, but in this case it relates to the clients table. Right, and all I did there was I just ran the query wizard and I selected the SQL view to get to here. Okay, that's that. So when we're wanting to do numerical queries, we just use greater than, less than, equal to, not equal to, as you would expect, with the field on one side and the number that you're comparing it with on the other. Here we're doing select just the description and the estimate from the task master list, where the estimate value is greater than 100. Okay, and there's the result of that query. Here are the conditional operators that you can use, or the comparison operators: equal to, less than, greater than, less than or equal to, greater than or equal to, or not equal to, which is just less than followed by greater than immediately. Sometimes you want to deal with text data, right? And with text data you have to surround the thing you're looking for in either apostrophes or at least single, I call that a single quote, or quotation marks, which I would call a double quote. Right, so that's there. Let's see if we can run that. Select star from clients. So let's go back to our, right, so select star. Let's grab that. So we're going to select star from clients, and then another keyword, SQL keyword, where zip equals 01431. And let's see if that Right, so there is our query, and we've got 3 clients with the zip code 01431. Now we should be able to go back to the design view and see it. And notice that the field in this case is everything, so we just say everything out of the zip table. Oh, sorry, everything out of the client table. Okay, let's move on. Dates are a little different, and here's an example, right, where we want to select projects with a start date bigger than 1st of the 1st 2021, and here we use the pound sign. It says you don't have to use 2 digits for the day and the date. You don't have to use the 4-digit year. All of them, as it says here, all of these lines here should be equivalent to what's in the picture up here. Right, and the aim is that all the project start dates are after 1st of the 1st 2021. Sometimes you want to compare 2 fields in the same query, and that's easy. You just put one of the fields on one side of the operator and the other field on the other side of the operator, just like this one here. Now, one thing I hope you noticed before, when I did my SQL version, I hadn't typed in clients.clientID and clients, etc. But the design view uses the fully qualified field names, right? So even if it's unambiguous where that field came from, it's sometimes a good idea to reduce the ambiguity and precede or prefix the field name with the client name followed by a dot. So that's what's happening here. Clients, I can't highlight that, clients.clientID and clients.clientName. Sometimes you need to have more than one condition on the data you're after. So for example, here we want to find all the programmers that earn a salary of less than 6,000. And that's how you do it. You use another keyword in SQL, keyword and. So far we've got select, from, where, and. I think we might have had create table previously in the earlier part as well. And similarly, the other sort of logical operation you may want to do is the OR operation. And does the union of the 2 conditions, sorry, the intersection of the 2 conditions, and OR does the union of the 2 conditions, right? So all people with title programmer and all people with a salary less than 6,000. So those 2 separate groups of people are then given as the result. Whereas the previous condition where that OR was an AND says that the programmer also has to satisfy the salary condition. Sometimes you want to check to see if a date or a number is between 2 limits, and that's where the between keyword is. Okay, I'm not going to go into that. That looks pretty straightforward. Sometimes the condition you want is something the opposite of the equality. So here we want everything except category ID being coding. So here the not operator is used instead. Other way we could have done this, I suspect, is to say where category ID is not equal to coding, but we decided that for whatever reason that it was easier to just put the not in front. I think we looked at this before as far as calculated fields. I don't think we explicitly did it in SQL, but it should be pretty straightforward. If we want to get the annual salary, we take the salary that's in there, which is a monthly value, we multiply it by 12, and that's going to be our annual salary. If we didn't say as, which is a way to relabel the result, give it a different name, then we'd probably get something a little strange as the name for that particular part. So here we want to be explicit that it's an annual salary, and we're doing that there. Right, we're using the as keyword, and we're calling this calculated thing annual salary. The wildcard operator is good for matching everything else or everything. So here we're looking for people with titles that are sort of like developers. So somewhere in the title there is the word developer, and we don't care what else there is there. It's just got to have the word developer somewhere embedded in the title of the person. And that asterisk, that wildcard operator, matches any string or no string. Okay. Sometimes we've got a series of things that we want to check for, and here we've decided that we want to find all the database developers, all the front-end developers, and all the programmers. So we've said where the title of the employee is one of those three, give me all their information. That's what this select star operator is doing. Sorting. Now we use the order by two keywords, and maybe we sort by client name, maybe we sort by client ID, maybe we sort by some other number. Depends on what query you're trying to answer, what information you're trying to get for an answer, what the right order by is. You don't have to sort by just one field. For example, we had 3 customers in that zip we looked up before, and we didn't specify what order those 3 should be in. So now we can order, if we're looking at the whole database, we can order first by zip, and then within a particular zip code we can sort by client name. And that's what sorting by 2 fields does. And then here's aggregate functions. Remember, aggregate functions are those things that take the either count the number of things, sum a particular field, find the minimum of a particular field, find the maximum of a particular field, or find the average of a particular field. Let's see if we've got the full list of them, maybe. So when we do an aggregate like this query is only going to return one result or one level of result. It's going to sum the total salaries in the employees table, and it's going to count the number of employees. And that's it. They're the only 2 numbers that are going to come out of that query. Sometimes we don't want to do that. Sometimes within the table, we don't want to summarize the whole table. Sometimes we want to get the salaries, the sum of the salaries of all the programmers, the sum of the salaries of all the product managers, the sum of the salaries of all the database developers, whatever their title is. So the way we do that is we use the group by construct, right? So here's an example where we're trying to count the number of clients in each zip code. So to do that, we use select zip, count star, and it's going to count the number given by how we group it. We're pulling it out of the clients table, so it's from clients. There's the group by zip, and then we're going to order by the highest number, the count star, and descending, so the biggest number is going to be first, and then secondarily the zip code is the thing we sort by. In case there are two zip codes that have the same number of clients, we're going to order within that number of clients by the zip code. Normal queries, the filtering operation is done using the where clause. Unfortunately, that doesn't work when you're doing a group by operation. So you have to, if you want to do some filtering on aggregate queries, you want to use the having keyword. For example, here's our query from before where we're grouping by zip, but the having keyword is allowing us to only find those zips where we have more than one client. If there's only one client in the zip code, we don't show that in the result of this. So subqueries, as the name suggests, are just embedded queries within another query. So here we're looking for the salary of somebody with employee ID 65, and then we're going to find all the employees in the employees table where their salary is more than employee ID's 65's salary. So that query within the parentheses at the last three lines of the query, that's a subquery of the main query. When there are relationships between tables, when there's a foreign key relationship, one-to-many relationship, or a one-to-one relationship, we need to join those tables. And the way we join those tables, here's an example, is to name the tables that are joined between in the from clause of the select query. So here we're selecting something from the clients and the projects table. And then our where clause tells us how we connect those two together. Here we connect the clients.client ID with the projects.client ID. Now this is a good way to make sure that client ID is unambiguous, right? Both clients table and projects table have a client ID field, so you want to do that separately. You don't have to just have one join. You can have three tables. Here's an example with three tables joined together, and again you just pull out the appropriate primary and associated foreign key and equate those, and then and that together with another primary and associated foreign key in order to move between, in this case, three tables: the clients table, the projects table, and the project line items table. The union keyword is used for when you want to connect together two otherwise unrelated queries and put the results in the same output. The selects in both have to have the same number of and type of fields, otherwise it doesn't make sense. But sometimes you want to do that. Here we're looking for all employees with a salary bigger than 7,000, and we want all the employees that are project leads as well. Their names or their IDs appear in the projects table. I'm going to leave it there. That is mostly about select statements. I'm going to do another video about the data changing commands.